those of you that have watched these videos, when it's on an angle like that, you can still see it, right? The angle helps that big giant glare bubble, which is why I do that. Okay. Okay. There, the AC kicked on. Okay. We will have an opportunity, guys, once we're done with these molecular formulas. It's going to take us a little bit, okay? So, I mean, I don't know, maybe half hour probably to get through these practice problems because it's a little bit complicated. We're going to have some time for you guys to ask questions about things that you have questions about, okay, in preparation for tomorrow's test. So don't be stressing, okay? Remember, if there's anything that's not clear, an added benefit of being able to make up your work prior to coming to class by me posting the videos is that those videos are there so you can go hear me say it again. And I recognize that if you were here and you sat through the 90-minute class, you maybe don't want to sit through the 90-minute class again. I get it. But sometimes just hearing it the second time, the light bulb goes off. You understand? So take advantage of that if I'm talking to you. And I don't know if I'm talking to you, but you should know if I'm talking to you. Okay? So, molecular formulas. We know that the empirical formula is what? Talk to me. Don't make me pull popsicle sticks. The empirical formula is what? You crisscross drop and reduce. So it is the lowest whole number ratio of those things, yes? Lowest whole number ratio. That's the reduce part, correct? Whereas a molecular formula tells us exactly how many. So if you remember, the molecular formula for glucose is C6H12O6. 6-12-6 is definitely not a reduced formula, correct? Definitely not in the affirmative. Definitely not a reduced formula, so it must be molecular, okay? What we did on Friday was we learned how to determine if we have a substance, we're not sure what it is, and we can evaluate it for how much of it is this element, how much of it is this element. We can then say the formula is this. Mathematically, we can determine that. Well, we can do the same thing in terms of determining a molecular formula. So if we have a molecular substance, and we analyze it, we don't know what it is, we analyze it, and we know that it's this percent carbon, this percent hydrogen, we can then determine its molecular formula, okay? We actually are going to determine the empirical formula first, and then we will take that empirical formula and go from there, okay? So this really is, determining molecular formulas really is a culmination of everything we've done in this unit. Okay, it's taking it all and putting it all together. Okay, and we're going to look at it in two ways. We're going to begin with the empirical formula and go from there, or, well, you'll see in just a second. Okay, you'll see what I'm talking about. Best way to do it is to do it. So here we go. This should be its. Tiny grammar lesson. IT apostrophe S or ITS?
ITS.
Yes? ITS. No apostrophe. Why no apostrophe?
Because it's possessive.
It's not it is. Because it's not it is. Very good.
Because it's possessive.
But usually when you have a possessive, It's apostrophe S.
Is it?
Michael's pencil, apostrophe S.
True, but if it's with ITS.
It
It.
is the exception.
Gotcha.
Right. So it's, yeah. Okay, so its empirical formula is CH4N. Now, okay, we're going to do this in a different way in just a minute, but this is our very first one. Okay? So this is the most straightforward. This is the bestest. The best way to start. Okay? So we have an empirical formula of CH4N, and we have a molar mass of 60 grams per mole. Okay? This is, we assume, because we are told calculate the molecular formula, this is the molecular molar mass, which means that this is the total mass of all of the parts in the molecular formula, which is the not reduced formula. This is the reduced formula. How do we know that? What word tells me this is the reduced formula? Empirical. Okay? So what we want to do is we want to calculate first. Good Lord, Kelly. That's empirical. The empirical formula mass. Empirical formula mass. Which means we're going to take the empirical formula and calculate its molar mass. Okay? So, 1 carbon at 12.01. 4 hydrogens at 1.01 apiece. 1 nitrogen at 14.01. I think those numbers are right. Is 14.01 nitrogen? Somebody tell me.
Yep.
Yes.
Okay. So somebody do that math.
28.2, 26.2, 30.06, I think.
Yeah, that's
30.06? Listen. 30.06 grams is the empirical formula mass. You with me? Empirical. 30.06 molar mass that is given to us is 60. You with me? Now, don't stress too much about it. If you want to use your calculator, you can, but I think you can probably do it without. Okay? By what ratio is the mass that is given to us larger than the mass that we calculated? 2.
It's close.
2 times larger, yes? Now, you can do the math. Go ahead and do the math, somebody. 60 divided by 30.06. And you're going to get 1.9. So rounded to the nearest whole would be,
2.
okay? So what we do is, very simply, okay, because this, and I'll go ahead and write the math down just so you have it as a model. So we're going to take 60.0, and we're going to divide that by 30.06, and we get 1.9 whatever, which is 2. We are going to take our empirical formula and multiply it by 2. Now, what that means is we have C1H4N1. We multiply each subscript by 2. So C2H8N2. That's the molecular formula. That's it. Bless you. All you have to do is take the empirical formula mass, figure out what it is, figure out how much larger, by what factor the one that they give you is larger. If it's a factor of 3, we would multiply all the subscripts by 3. If it's a factor of 9, we would multiply them all by 9. Yes? It's pretty straightforward. Okay? right, let's do another.
Okay.
Give me just 1 second. It's super,
I think it's 184.5.
super causing me stress.
Yeah, it's revolves.
This won't make it perfect, but it'll make it better. All right. This is CCLN. What is the empirical formula ratio right now? What is the ratio of C to Cl to N? 1 to 1 to 1. Okay? So we have an empirical formula of CCLN. We have a molar mass of 184.5 grams per mole. And our molecular formula is the question. Okay? So we're going to take CCLN and we're going to figure out its molar mass. 1 carbon at 12.01. 1 chlorine at 35.45.
Yeah.
And 1 nitrogen, 14.01. What's this math? Somebody hit me.
61.47.
0.47 grams per mole. So what's next? We figure out by a factor of what whole number is 184.5 bigger than 61.47.
3.
So 184.5 divided by 61.47. What's the exact math?
3.00146.
00146,
Keeps going.
which is what whole number?
3.
3. So we take our empirical formula and multiply it by 3. So we end up with C3, Cl3, N3. Yeah?
Yeah.
It's not bad. Anybody need this screen? All right. Ah! I really thought I had another kind of practice problem. No. Give me a second. Michael, hold up. It's okay. 331. 331. 631. Imperial formula. Yeah. Did I assign one of these with the sub?
Yeah.
Yeah, 331.
331, 39A and 331, 40. I did assign that with the sub. All right, let me look at 333. 333. 42, 49. 42. Mm-hmm. 49. Yeah. Hit it. Right now. 333, number 42, and 49. Right now in your notes. Make that happen.
Middle schoolers can play on the JV baseball.
8th grade is eligible to play on JV. Listen. Shh. People, I need everybody to go to page 333, and I need everybody to look at number 49. Get your pencil out of your hand. I don't want nobody writing nothing for just right now. Please look at 49. You're going to do 42 first. It's just like what we just did. Yes? Easy peasy, no problem. Look at 49. The compound methyl butanoate smells like apples. It does. It's an organic compound. Its percent composition is 58.8% C, 9.8% hydrogen, 31.4% oxygen, and its molar mass is 102 grams per mole. What is its empirical formula? What is its molecular formula? You will take the 58.8, the 9.8, the 31.4, and you will get those into grams. Remember, we assume 100 gram sample, so that's how many grams you have. Yes, the percentages that are written there. You take each of those three-dimensional analysis problems, convert them all into moles, write the empirical formula from there. The first part of number 49 is Friday. Do you understand? It is Friday. Then, once you have that empirical formula, you will take the 102 grams per mole and figure out the ratio and do what we did today. So it's Friday, it's Monday, today's Wednesday. It's Friday, it's Wednesday, together in one problem. Yes? Go. No. You're just doing page 333, 42, and 49. You have already done page 331, 39, and 40.